Good morning, everybody. How are we doing?
Great.
Trying to find my Greg Sizemore attitude this morning. So, we gotta own it, right? Yeah! Okay, so we are doing the alternate presentation for the Fort Lauderdale Aquatic Center, and we are alternate construction. Today I'm gonna give you 4 options: cast in place, cold form metal, steel, fiber reinforcement, and safety, quality control, and environmental. Our mission is to deliver a proposal for a construction dive tower that is 27 meters high at the Fort Lauderdale Aquatic Center in Florida. This tower is designed for precast construction concrete, and we believe that there are better alternatives due to the downsides of the lead times, workforce, and cost. And I am Abigail Spildy, representing the University of Wisconsin-Platteville.
Hello everybody, my name is Leonidas Hernandez and I'm with Fresno State.
My name is Carlos Marquez and I'm with the University of Central Florida.
My name is Jose Mendez with the University of Southern Mississippi.
Morning everyone, my name is Alejandro Giraldo and I'm with the University of Central Florida.
Good morning everyone, my name is Caroline Collins and I am with Louisiana State University.
Good morning, my name is Juan Bankhead with the University of Southern Mississippi.
Hello, my name is Harrison Redeker, and I'm from Kent State University.
Good morning, everybody. My name is Mitchell Petchard. I'm here representing the University of Wisconsin-Platteville. I will be starting us out with our first of our 4 materials. This will be the casting in place. As you can see on screen, we have the critical path for this one. It has a total duration of 88 days. And this one is different than others as it will be built by us and pulled from 3 miles off in a laydown yard. The total estimate bid is going to be $852,120.
Gotcha. Moving on to cold form metals framing. Getting into the schedule, it'll be a total of 317 days, with reconstruction being 93 days, going into pouring foundation being 5 days. The construction of the dive tower taking 224 days, placing of the steel components will be 65. Auger pile end caps will be 10 days, and MVP will be 140 days. Going into the estimate, the bid will be $1,176,588. On to Juan.
I'm going to be speaking about the steel. The critical path duration for the steel was 122 days. Procurement will take 65 days, pouring the foundation 5 days. Hanging and detailing on the steel will be 51 days. Placing the components is 65 days. The punch and closeout inspection is 6 days, and the MEP will run concurrent with placing the steel components. The estimate is $1,183,470.
And last but certainly not least is our fiber reinforced polymer, also known as FRP. One of the really cool things about it is that we are using both cast in place concrete and the FRP on the outside once the cast in place has been completed. And once that is done, we have a grand total of $558,183.30. And in fact, we actually chose to do the FRP option due to the longevity, durability, and slip-resistant elements of the FRP. We believe that the FRP will last 50 years, and as a result of that, it will decrease the cost to maintain the dive tower for years to come. In addition to the fact that it is slip-resistant, the slip-resistant allows the divers to be going up and down the dive tower repeatedly with less of a risk of slipping after doing it multiple times.
We here at Alternate Construction take quality control very seriously, and we will always do so. During this project, we will have our quality control phases divided into 3, a preparatory, initial, and follow-up phase for inspections.
As you can see, we have provided some.
For inspections, we will be making sure that every step of construction is done right. That does include some subcontractors. We will do everything we can to make sure that they do the job right and that they do it in a safe and efficient manner.
I will be talking about the safety action plan as it entails a swift, safe response to dive tower incidents and suicide diver incidents and adherence to protocol. As you can see, we have provided some important locations that include the closest hospital and the closest fire department in case of an emergency. And for an emergency in brief, we will add, assist, protect, aid, and guide the situation.
As always, we want to make sure that our crews are safe and protected, so we will be requiring everybody to wear their personal protective equipment, such as a hard hat and a high visibility vest. Because of the proximity to the ocean, we will have life vests available for everyone in case there's any maneuvers that will need to be done close to the actual ocean. When it comes to the crane usage, we need to make sure that we have adequate supporting mats. We will be using shorings to make sure that the pools do not cave in once the actual crane is in place. We need to make sure that the swing radius barricades are put up so that nobody unauthorized goes into the area where the crane is being used, and that there is constant communication with the operator and all of the spotters around the crane.
Now, because we are focusing on a dive tower, we did want to emphasize the importance of fall hazards and making sure we address them. All work sites that have a trench or an elevation over 3 feet will have signage to show that there is a fall hazard there. Any worker working over 6 feet or using something like a boom lift will be required to wear any type of fall arresting system or harness, and we will follow that to a very, very strict T.
Now we will be going over environmental. So with this environmental, we wanted to dive deep into making this project a sustainable and efficient project for the environment for Fort Lauderdale. And some of these specific factors show the embodied carbon emissions for each construction material we talked about previously. Some of these factors include the transportation, which will cause a lot of high emissions, as well as the raw materials when mining for some of these, such as the cast in place tilt-up, and as well as the production and manufacturing of each material. But some of the factors that can contribute to us gaining LEED points for our LEED certification can be things like choosing a low VOC finish or sealant, sourcing out to a local supplier, and reusing recycled material to gain some of those LEED points. Since we did go with RFP, you can see on the slides where it says petroleum-based resins use fossil fuels, which use more emissions, which create more emissions. In turn for that, in lieu of that, we can use bio-based resins for sustainability. And with that being said, I'll pass it on to Abby, who will be closing out this presentation.
I just wanted to say an extra thank you for all of you today and being willing to hear us, and if any questions you may have, I would like to open up the panel.
So all of the construction practices you have for the tower are really kind of normal stuff we would use. Did you guys talk about doing anything crazy like building out a carbon fiber or anything like that?
We had some talk about some timber, but after that thought, it was, no, that's more residential. It's not hefty as usually you'd see it for a concrete dive tower, but I can pass it on here.
Yeah, I was going to add on to that, and because it is close to the ocean, timber wouldn't be such a good option for longevity, because after a certain amount of years, that'll deter and not be good for the structure, the overall structure.
But going off of mass timber it is definitely a sustainable choice. And that's the biggest thing with that one. So it would definitely help with LEED accreditation. And I'm sure that there could be methods to make it more resistant to salt and deterioration.
From a safety standpoint, you guys talked about call it grade level components, but didn't really touch upon anything as you're building the tower or trying to complete the facade of the tower. Did you put any thought into how you keep personnel safe as they're erecting the final pieces or touches to the tower?
I mean, when it comes to erecting the tower, it's all pretty standard safety protocols to wear harnesses and fall arrest systems. We pretty much held that same standard when it came to thinking about how they were going to erect those final pieces. We would have people around to make sure everyone was doing, using the right harnesses and wearing all the right gear to prevent any type of serious
accident happen.
One thing with precast, you can control the quality of the finish of the panel a lot easier than at a batch plant or at a precast fabrication yard. Everything's right there on the ground. Finishers can easily access the panels, or you can use textured liners to get the desired finish you want. So the cast-in-place option, does that price include, smooth face forms for like a Class A finish? There's a little bit more effort involved in making cast-in-place look as nice as precast.
So in the final estimate, we did include forms. However, we did not use a smooth finish. I can reevaluate those numbers after and get back with you about that. But in the estimate, I included sandblasting to have a rougher surface to attach the FRP.
I want to add on to that. With the cast-in-place tilt-up, we were planning on doing the cast-in-place off-site, and then once we get that poured, then we would bring it on-site, transport it on-site, and tilt it up to the tower.
Were there any considerations for when you were evaluating the different materials? Given the height of the tower, were there any restrictions on how out of tolerance and plumb you could be, and did the different materials play into that and your final decision?
Yeah, definitely. I believe it was the cast-in-place where it was like a maximum of four stories tall, where the dive tower was going to exceed that for sure. So I can't remember if it was a cast-in-place. Okay, so yeah, it was. You can touch on it more, but.
I mean, yeah, the biggest thing with all the choices that we made was ensuring that the max height would be considered, like cold form metal framing and definitely steel, is it would definitely be exceeding that 100-foot tall dive tower. For the concrete, it might be a little bit more difficult, but I'm sure that there would be some method to kind of accommodate the missing feet, but I think it is definitely possible to get it up.
I have a question unrelated to how you built it. How many of you were jumping off the top deck?
That's what I'm talking about.
Another thing about the different, when you're evaluating the different types of materials, each one has a different erection sequence or amount of space needed to build that tower, right? So walk me through a little bit of the thought process. Structural steel versus cast in place, your FRP, you had cold form metal framing. You don't have a lot of room there, so what were the considerations and what was included in the estimates for that?
Definitely for the cold form metal framing is getting a steel outline. Not of course as heavy as actually doing the entire thing made out of steel. It's definitely building up layer by layer, so it would definitely save on material storage, so it would be a smaller laydown area for definitely the cold form metal framing. So you can build it up, getting your slab on decks, and building it up kind of like a house a little bit. But you guys talk about that one.
We would be coordinating with the producers as it is made, and we'd be bringing it in as we use it. So there would be minimal laydown area, but we would definitely plan out a week or two in advance to make sure that we have enough on task that we're not being slowed down by not having our materials in place.
All right, well, thank you guys so much. You guys did a wonderful job, and I appreciate the level of effort you guys put in, so thank you so much.
Thank you.